Welcome back, everyone. Special edition of Econ 380. Basically, what I'm going to be covering today is chapter 12 and 13. So this is just another recorded lecture that you have available to you to go over this material. I know this week has been very difficult, from class cancellation to the holidays and so much more. So again, I'm going to walk you step by step on how to do some of these problems, how to tackle this. This will show up on your next exam as well as your final. So you can always go back and reference this. This will help you. Again, there's only so many different things I can do for these types of questions. So you'll kind of be able to see where my head's at in terms of setting up these problems. And we'll go through it step by step. Okay, so this is arguably the problem that's going to take you the longest on your second exam as well as your final. And it's all based off steps. So I've mentioned these steps before. What we're trying to look for is a two-sample t-test. A two-sample t-test is when we're comparing two different populations or two different groups. Anytime you have two samples, you should automatically think of running a two-sample t-test. Remember, when we look at t-test, this is always looking at means or averages. So that's what gives it away when you have two groups and you also have means included. Now, in order to run a two-sample t-test, these are your steps. So your first step is to set up your null and your alternative for your two-sample t-test. Now, whenever we look at t, this is referencing our averages, and the best parameter to use is mu. So this is what your setup's almost always going to look like. So this would be your null hypothesis, and your alternative would look something like this. It could either be greater than the same value. I'm sorry, yeah, greater than, less than, or not equal to. And this all corresponds to what type of test, whether it's one-tailed, two-tailed, or and so forth. Now, what our null hypothesis is saying, mu1 minus mu2 equals 0, is saying that there's no difference between the two groups. Now, what we're trying to test is there is some type of difference. If it's greater than, that means mu1, or our population mean 1, is greater than our population mean 2. If it's less than, that's saying mu2 is greater than mu1. If it's not equal to, this is just saying it's going to be any other value but 0. So there is some type of difference. We just want to see if there's a difference. All right, now in order to run a two-sample t-test, we need to conduct an f-test. An f-test is looking at population variance of two different groups. So in order to run a two-sample t-test, we have to run an f-test, and our null and our alternative will always look like this. Again, there are cases where it's a little different, but I'm telling you, for your exam, for your final, this is what you're going to need to know. So this is how it's always going to look. So it's population of population variance of group 1, population variance of group 2 equals 1. This is saying that there's no difference between the two. Your alternative is it is not equal to 1, meaning there is some type of difference. Now, anytime you conduct a test, you're going to need some type of critical value. You need some test statistic and make a decision. So the reason why we run an f-test is because it's very rare for us to know our population variance. So instead, we have our sample variance. That's why we run our f-test, to assume equal variance or unequal variance. From there, we can go ahead and carry out the appropriate t-test, assuming equal or unequal variances. Now, as soon as you run your f-test, you get your decision. You can either fail to reject, or you can reject your null. So you can either fail to reject or reject your null. From there, there are certain formulas that you're going to need to know. And I'm going to cover those in this slide as well. Okay, so after you know what to assume, equal or unequal variances, there's certain t critical values, t statistics that you can carry out. And from there, it's pretty much standard. You use your t table for any t-test. So t table for your t-test. You make your decision, answer with some context, stuff we've been doing. And we're going to reiterate this the day of our review as well. And then the last thing I can potentially ask you is confidence intervals. So remember, I've mentioned your formula sheet before. You should be dividing it up into quadrants for all the different types of tests that we've had. These tests include anything that looks for population mean. So this is our t-test. Population variance, this is your chi-square test. Population proportion, this is your z-test. Now we also have your two-sample t-test. And then we also have our f-test. So it's two-sample t-test, very similar to a t-test. Our f-test, very similar to a chi-square test. It's just using two samples. All right, so because we want to find the differences between two means, and it's almost impossible to get our population mean for any group, we're going to be using the best statistics we have available, or the best unbiased and consistent estimator of mu, which is X bar. So a lot of these slides you have, these are our conditions for looking at X bar 1 minus X bar 2. This is technically what our Z stat would be if we knew these values, but we do not know these values. So I don't want you to write this formula down anywhere. We don't know these values. That's why we conduct an f-test. We want to assume if they're equal or unequal. So in order to carry out a two-sample t-test, we have to make some assumptions first. So here we have our F distribution or our F test. Remember, we've looked at our test statistics. So our F stat, this is our evidence, right? So it's our sample variance 1 divided by our sample variance 2. Now today we'll go over a practice problem where I give you this information. You'll see what it's probably going to look like on your exam and your final. Again, this problem takes a long time, so I'm going to try to help you as much as I possibly can by doing some of the calculations for you. But you need to know what these mean. So this is your F stat. So I've already told you before our null and alternative for our F test. Remember, we run an F test to determine equal or unequal variance. How it's always going to look on your exam. If you have anything different, you did something wrong. So because it's not equal to, this is going to be a two-tailed test, meaning you need two critical values. This is our F stat. In order to get our critical value, these are the ways you get your critical value. So your F critical value, just give me 1 second. Is alpha divided by 2. It's alpha divided by 2 because this is a two-tailed test. Comma the V1, which is N1 minus 1, comma N2 minus 1. So just degrees of freedom, what we have here. Now the other critical value, it's 1 minus alpha divided by 2, comma N1 minus 1, comma N1 or N2 minus 1. So just again, degrees of freedom. If you fall within the rejection region, you would reject the null. If you fail to reject, meaning you aren't in the rejection region, you fail to reject the null, assume there's not enough evidence for the alternative. Okay, so again, pretty straightforward. You just need to know these formulas. This is how you run the F test. So when you are running your F test, essentially what you need to know are the formulas on this slide here. This is how your null and alternative will always look. Remember, this is step 2. We have to conduct the F test. All right, so this formula right here, this is how you would originally get your critical values, your probabilities, but we do not need to know this. This is a much higher level that we aren't going to get into because we have tables, thankfully. So after you conduct your F test, the whole idea is to be able to use certain formulas. So for example, if I were to run your F test, And your first decision or potential decision you can have is if I reject the null hypothesis. So remember, this is our so if I reject the null hypothesis, we assume unequal variance. So based on your decision, if you reject the null, meaning you have enough evidence to conclude, we assume unequal variance. So if you were to just write this on your exam, you'd be totally fine. Again, anytime you run a test, you always need decision, but this is just for your F test. Now, your second potential decision is you fail to reject the null. If you fail to reject the null, we are going to assume equal variance. So this distinction is very important because it's going to lead to different formulas that we can use. So that is extremely important. I want you to know that. All right. So again, this is your F test. This is how your null and your alternative will look. You have your test statistic, you have your critical value, and you have your rejection regions. So I don't want you to have to worry about p-values. We're not going to worry about p-values. So this is your rejection region. Again, this is just another way of saying if it falls within the shaded area, we would reject. If it's not within the shaded region, we would fail to reject. So again, try to keep these in mind. These are very important. And we're going to do a practice problem today to help reiterate this. Now, when you run an F test, you have an F table. This F table is posted on Beachboard. It's under the content section. It's also posted, or it's also on the back of your textbook if you have your textbook. So feel free to download those. Those will be very important. If you have questions about how to use a table, we'll be going over all the tables on our review day. Also in this video as well. So this is our F table. This is one of our many F tables that we have. Here in the corner, you see A of 0.025. That means this is alpha of 0.025. Then you have all of these columns. This says V1. So this is the degrees of freedom for group 1. V2, this is the degrees of freedom for group 2. So if it's F of 0.025, comma 7, comma 5, if we were to look this up. So we're on the right table because of this. Now this is V1, this is V2. So for V1, I would go to column 7. And then I would go to row 5. Row 5. So where they overlap is 6.85. That's how you use your table. And for the most part, students tend to do really well at the table, which is awesome. I haven't seen any big issues. Here we have a table. Our alpha is 0.05. So one thing I have noticed students do in the past, they forget what table they're looking at, or they forget the alpha that they're looking at. So please make sure to know which table you are looking at. Very, very important. Here alpha is 0.05. So let's just say we're looking for F of 0.05, comma 5, comma 7. So we're on the right table. This is V1, this is V2. V1 is 5, so now I'm going to column 5. You get the picture. And then we're going to row 7. Where they intersect is 3.97. So this is one of your critical values. So 3.97 is your value. Now, if I wanted to flip this around, if I did 7 first and then 5 second, our values would be different. So if we're on column 7, row 5, we get 4.88. So it is very, very important to know which values go where. So do keep that in mind. Okay, so on our next slide, what we're going to be doing is covering a practice problem for running an F-test. So you're not going to have a standalone problem running an F-test. I just want to show you how the steps are taken. All right, so give me 1 second. All right, so we're going to do a practice problem now. So here, suppose that a quality controller collected random samples from 2 container filling machines. Can we infer at the 5% significance level that the first machine is superior in its consistency? So in this case, what we're trying to test is looking at consistency. And what we tend to see with consistency is our variance. So this is a standalone F-test. I will never ask you for a standalone F-test. The only reason I'm showing this is so you have some exposure with this type of problem. So here we're running just the F-test portion. So our null and our alternative. Remember, I told you this will never change. Now in this problem, it's supposed to be greater than 1. The reason why it's greater than 1 is because it's saying the first machine is superior than the second machine. But for our case, we're going to do not equal, because that's, again, we're just changing up the words, but it's still, this is what you're going to see on your exam, and that's what I really want us to practice. All right, so you set up your null and your alternative. The next step, find your F critical value. So you know our F stat is your sample variance 1 divided by sample variance 2. So it's 0.6333 divided by 0.4528. What you should get as an answer is 1.40. So this is your F stat. This is your evidence. Now, if you see a not equal sign, you know this is a two-tailed test. The next step is we need our F critical value. F critical value is F of alpha divided by 2. The reason why it's alpha divided by 2 is because two-tailed test, comma, n1 minus 1, n2 minus 1. So what we're going to be looking for on our table is our F critical value of F of 0.025, comma 24, comma 24. And then the other F that we're looking for, remember you need upper and lower bound. It's going to be 1 minus 0.025, comma 24, comma 24. Okay. So we're going to first start off by the first one, and I'll show us a little trick about how to solve the second one. Okay, so F of 0.025, when you go to the correct table, it would be this table right here. I'm just going to erase some things. All right, so what we're trying to look for is this value. So 24, 24. We see 24 here, so we're going to highlight this column. And then we also have the row of 24. Where it intersects is 2.27. So you're going to have to give me 1 second. Let me just double check the math. All right, so what we found right now, this is our upper bound. What this means is if we look at our distribution, we got the right-hand side. So this is 2.27. Now we want to find the other side. A quick trick on how to calculate the other side without using your table is just doing this. So we could do 1 divided by f of 0, I'm sorry, f of 1 minus alpha divided by 2, comma v2, comma v1. The key thing here is to switch these two values. In this case, it works perfectly because they're both 24. Now, we already know what our bottom portion is. So it's going to be 1 over 2.27. So this right here is what goes underneath. Now, what we're going to be left with is 0. Let me just double check the math. It's going to be 0.44. So this is our lower bound. So again, the shortcut is also on the previous slide. So the shortcut is listed right here. Now, some students, what they do, they forget to switch the V2, V1. Do not always assume that the degrees of freedom will be the same. Sometimes it will be different. So that's your shortcut. You flip these and you get your lower bound. So this is your lower bound. This is your upper bound. So meaning this is right here, and then this will be right there. Okay. So we know our values, it's 2.27 and 0.44. Our F-stat is 1.40, which lies right here. So 1.40. Again, if you understand testing and what we've done so far throughout the semester, you would say that you would fail to reject the null. So in this case, we failed to reject the null, and we would assume equal variance. If we fail to reject the null, we assume equal variance. If we reject the null, we assume unequal variance. That's how you run your F-test. Now, the reason why this is so important is because of this decision. We need to know what this decision is. If we assume equal variance, these are the steps that we are going to carry out. So what I want you to do for this slide, please make sure you have this down in your notes and have it starred, whatever you need to do. It's extremely, extremely important. So if this is what we do when we assume equal variance. So in order for this to happen, we fail to reject the null of our F-test. That's when we use these steps. So this is your T-stat. It's the difference between x bar 1 minus x bar 2. These are values that will be given to you, or you might need to calculate. You have the difference between mu1 minus mu2. This is always given to you by your null hypothesis of 2-sample t-test. You're going to divide that by your square root of what we call your pooled variance. So your pooled variance, this is something I've given to students in the past before, and I still see students calculate these values. Make your life easier, understand the symbols that I provide you. Extremely, extremely important. Okay, so that is your test statistic. Now your degrees of freedom. Remember, we're running a t-test, 2-sample t-test. You're going to be using your t-table. So your t-test, your degrees of freedom is t of alpha, comma, v. This v is n1 plus n2 minus 2. This is extremely important. This is what goes in right here. From there, you should know how to make the decision. It's a left tail test, right tail test, or a two-tail test. If it falls in the rejection region, if it doesn't fall in the rejection region, you can be the judge of that. And lastly, with any test, there are always confidence intervals. So this is our confidence interval for our 2-sample t-test if we assume equal variance. You have the difference between your means. This right here is your critical value. You have your pooled variance. You have your sample. You should be able to plug all these values in. And again, I promise we will do a practice problem in a bit. Okay, now if we assume unequal variance, this means that we rejected the null of our f-test. Now, our test statistic looks different. It's the difference between mean 1, mean 2, divided or subtracted by population mean, which we still get from the null hypothesis of our 2-sample t-test. But we divided by our sample variance and our population or our sample size. And we take the square root. So here, there is no pooled variance. That's one of the key differences. No pooled variance. Now your t critical value, this one gets a little bit more intense. It's alpha, and you still have your degrees of freedom, but to get your degrees of freedom, this is what you're going to be doing. You're going to use this formula for your degrees of freedom. Now the decision, the rules still apply. If it's a left tail, right tail, or two-tail test, you compare your t-stat to your critical value, which we seem to have no problem with so far in the class. Now our confidence interval has also changed. So this is our confidence interval assuming unequal variance. This is your critical value. Now you don't need to use pooled variance. Similar setup. Again, know the difference between the two. So you have a 50% chance of me asking you something has equal variance, 50% chance of me asking you unequal variance. And if I ask you for equal variance now on the final exam, I might ask you for unequal variance. So just a little heads up. So keep that in mind. So degrees of freedom are different for unequal variance compared to equal variance. So here our degrees of freedom are just n1 plus n2 minus 2. Here degrees of freedom is this super intense formula, which again, you should have. Putting this into your calculator might be a challenge, but do it step by step. Extremely important. Okay, so now that we've done that, I want to carry out some practice problems. So these are what most of you came here for. This is what's going to really help you hone in on this skill. All right. All right, so millions of investors buy mutual funds, choosing from thousands of possibilities. Some funds can be purchased directly from banks or other financial institutions, while others must be purchased through brokers. Then some of these brokers charge fees for their services. So this raises the question, can investors do better by buying mutual funds directly than by purchasing mutual funds through brokers? So you can kind of see we're comparing two different groups. If you buy funds directly or if you buy it through a broker. We're going to try to see who has the better return. All right, so to help answer this question, a group of researchers randomly sampled annual returns from mutual funds that can be acquired directly and mutual funds that are bought through the broker and recorded their net annual returns. So these are your return on investments after deducting all relevant fees. So they give you an Excel spreadsheet, which we're not going to be using. I will give you all the important values. So now the question is, can we conclude at the 5% significance level that directly purchased mutual funds outperform mutual funds bought through brokers? So we have our two groups, directly purchased and bought through the broker. We want to see if group one, which is directly purchased mutual funds, the reason why this is group one is because they are named first or they're listed first. If they outperform mutual funds bought through brokers. So essentially, we're trying to compare the difference between two groups. So again, you see two samples. again, we haven't covered a lot of different two samples, so you know it's gonna be a two sample t-test. This is how our null and alternative will look. So our null is always gonna look like this, meaning there's no difference between buying it yourself or going through a broker. Now, what we want to test, again, which is in the sentence, is if group 1 outperforms group 2. So group 1 is directly purchased mutual funds. The second group is mutual funds bought through brokers. So this would be greater than. Anytime you see greater than, you know this is going to be, I'm sorry. You know this is going to be a right-tailed test. Now that's going to be the ending of our two sample t-test. In order to run a two sample t-test, what do we need to conduct first? I know you're not in class, but I want you to say it. You said f-test, you are correct. Steps, that's the biggest part of this exam. If you don't know your steps, you will not do well. So this is your first step. Second step, you have to run an f-test. So we need to run some type of f-test. So that's what we're going to be doing. I'm going to be putting stuff up on the board, and we'll be doing this together. Step 1, we had our null, we had our alternative. All right, so now I need to provide you with some values in order to even carry out this problem. Okay, so group 1, we've said already, it's directly purchased. Group 2 is for the broker. So sample variance for group 1, 37.49. And these are stuff that will be given to you. So you don't need to come up with these off the top of your head. We have N1, which is 50, N2, which is 50. We know our alpha is 5%. That was given to us. Some other values that you're going to need is X bar 1 is the average returns, or the net annual returns is 6.63%. Average returns for through the broker is 3.72. Now, our second step is we want to run the f-test. So your f-test, remember, you have to set up your null and your alternative. And I told you already that your null and your alternative is going to be looking like this every single time. If you have anything different, I promise you did something wrong. So you know this is a two-tailed f-test. Now, we need to calculate our f-stat. So our f-stat formula is a different, or the you divide your sample variance divided by your sample variance for your two groups. So it's 37.49 divided by 45.34. The beauty of this is you can pause this video, divide it out, and double check your answer. So what I got is 0.86. If you got something a little bit different, totally fine still. Again, I'm worried about the steps. So you have your f-stat. Now you need your f critical value. So remember, f critical value for a two-tailed f-test is as such. F of alpha divided by 2, comma, n1 minus 1, n2 minus 1. So what this looks like is f of 0.025, comma 49, comma 49. Remember, this is our upper bound, and our lower bound is f of 1 minus alpha divided by 2, comma, n1 minus 1, n2 minus 1. Now the shortcut I showed you, it's 1 over f of 0.025, comma, 49, comma, 49. So the good thing, remember, all you would do is switch these two. It's beneficial here because they're both the same exact value. So this would be your lower bound. Now your f of 0.025, comma, 49, comma, 49. What you are going to get, because there's no 45 or 49 on the table, you round to the closest value, which would be 50. We would get 1.75. Now, if we were to plug this into our other value, it's 1 over 1.75. What you get is 0.57, somewhere around there. So for your F test, remember it starts at 0 because you can't have a negative variance. You have your upper, your lower bound. So this is 1.75. This is 0.57. Now what we want to compare is our F stat. Does our F stat fall in the rejection region? Yes or no? You should be shaking your head no. This does not fall in the rejection region. 0.86 is somewhere here. So if it falls in the fail to reject, so if we fail to reject the null, we are assuming equal variance. So we are assuming equal variance. Now from here, you can conduct certain steps. All right, so we failed to reject our null. So we're assuming equal variance. There's certain steps that we have to take. So this would be our third step. So our third step is compute our t-stat. Our t-stat for assuming equal variance. You have the formulas on your table and also the slides. So if you rewind a little bit, you'll be able to see it. It's x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by your square root of your pooled variance, 1 over n1 plus 1 over n2. Okay, so now in order to do this, we need to solve for our pooled variance. Now on the exam, I will give you your pooled variance. I'm telling you right now that I'm giving you your pooled variance, so you should believe me. So your pooled variance, the formula, just in case on the final, if I don't do that for you, is as such. Again, you're plugging all these values in, all you need to know is a formula, and you have a formula sheet. So again, work smarter, not harder. So if I were to plug all of this in, let me just double check if I'm still recording. All right, so if I were to plug all the values in that I have for this, so it would be 50 minus 1, 37.49 plus 50 minus 1, 45.34 divided by 50 plus 50 plus 2. The value I would get in return is 40.42. So 40.42. Now I'm just plugging in every other value that I have for my t-stat. So x bar 1, x bar 2, 6.63 subtracted by 3.72 subtracted by the difference between this. So I get this from our null hypothesis. So it's just 0. Again, it's given to you in your null, divided by the square root of 40.42, 1 over 50 plus 1 over 50. Now, when you do all this math, you can pause the video, get your actual calculator out, do the math. What it's going to return is a value of 2.29. So this is your t-stat. This is your evidence. Anytime we have our evidence, we need to compare it to our t-critical value. So give me 1 second. So our t-critical value is what's next. And this should be familiar to you. So our t-critical value for equal variance, remember, we're assuming equal variance. There are certain steps for equal variance and unequal variance, is as such. So our degrees of freedom is n1 plus n2 minus 2. And remember, our alpha is 5%. So it's t of 0.05, comma, 50 plus 50 minus 2. So it's t of 0.05, comma, 98. When you now look up this portion, this should look familiar to you. You go to your t table. So you go to your t table and find this. So you can pause the video, find it. And when you come back, you're going to realize that the value it returns is 1.66. Now, the type of test we are running, our two-sample t-test, the type of test itself is a right-tail test. So if I were to draw this out, it's a right-tail test. Anything greater than this critical value, we would reject. And our critical value is 1.66. And our t-stat, you all guessed it, is 2.29. So in this case, our decision would be reject the null and assume that if you purchase your own mutual funds without going through a broker, you're going to see higher returns. So something along those lines and so forth. So I know it can be extremely time consuming, but the steps is what I care about. Okay. Now, the next portion would be, let's just say I ask you for if I ask you for a confidence interval. So if I were to ask you for a confidence interval, assuming equal variance, so continuing on with this problem, give me 1 second. So if we're continuing on with this problem right here, so I'm going to put in my t-stat was 2.29. My t-critical value was 1.66. Now, the formula for, again, assuming equal variance for a confidence interval is this: x bar 1 minus x bar 2 plus or minus t of alpha divided by 2, comma, our pooled variance, 2p, this is pooled variance, 1 over n1 plus 1 over n2, it's the square root of this. All right, so our pooled variance again was given to us 40.42. Now I'm just plugging in values. So 6.63 subtracted by 3.72 plus or minus. Now our t critical value has changed. So it's t of alpha divided by 2. So t of alpha divided by 2 comma, our degrees of freedom. So it's T of 0.05 divided by 2, comma, our degrees of freedom still remain the same. So 50 plus 50 minus 2. So what I'm trying to look for on the T table is 0.025, comma 98. What this is going to return to you, remember you go to your T table, it's going to return 1.984. And again, you just plug in your values. 984 multiplied by the square root of 40.42, 1 over 50 plus 1 over 50. Now, my final answer, again, you should be able to plug this in and know what your LCL and UCL are. So here, what I'm asking for is 95% confidence. The reason why it's 95% confidence is my alpha is 5%. So again, this will be given to you in the problem too. So 95% confidence interval. My LCL is going to come out to 0.39. UCL is going to come out to 5.43. So a way you could answer this is with 95% confidence, we can assume that the return is between 0.39% or 5.43%. So again, you have your confidence interval. This is how you do it for equal variance, if we assume equal variance. Now for our next practice problem, we are going to do one for unequal variance. So again, you'll have a mix of both. So we're going to go back to our slides. So our next question is, what happens to the family-run business when the boss's son or daughter takes over? Does the business do better after the change, does the business do better after the change if the new boss is the offspring of the owner, or does a business owner do better when an outsider is made chief executive officer or CEO? So in pursuit of an answer, researchers selected 140 firms between 1994 and 2002, 30% which passed ownership to an offspring, 70% appointed an outsider as their CEO. So each company, the researchers calculated the operating income as a proportion of assets in the year before and the year after the new CEO took over. So the change, so the operating income after subtracted by your operating income before, and the variable was recorded. And here is our actual question. Does the data allow us to infer that the effect of making an outsider offspring is different from the effect of hiring an outsider as CEO? So the key word that you should focus in on, you have two groups, obviously. So somebody who passed it on to an offspring, someone who hired someone as an outsider, two groups. So you know it's two sample t-test. The next is different. So anytime you've seen different before, it's not equal. So here we have our breakdown. We have two populations. The first population, income of companies whose CEOs and offspring. Population 2, CEOs and outsider. What we're trying to calculate is the difference between these groups. And this is what our null and alternative will look like. So this is our null and our alternative. It's not equal. So if I were to ask you in class if this is a one-tail or two-tail test, you would be saying it's a two-tail test. So you have two critical values, you'll have your evidence, you make a comparison. So this is for your two sample t-test. So this is what we're going to be doing. We'll be doing our practice problem together as a class. Follow along, extremely, extremely helpful. Okay, so our first step, again, state our null and alternative. We have group 1, so with offspring, group 2, outsider is 0. We want to see if there is any difference between the two. So two-tailed test. Now, some of the values that you need in order to tackle this problem, again, you can pause this video after I write all this down, and you can go ahead and try to carry it out, see what you get. 3.79. Group 2, it is 8.03. So real life application of this could be, okay, should I hire someone outside of my outside of my family? Or should I pass it on to a family member? Another key thing to remember here, look, if you see the two sample sizes, they're different. It's not 50 and 50 now, it's 42 and 98. So my alpha is 0.05. On the exam, I'll give you what alpha is. X bar 1 is negative 0.10. X bar 2 is 1.24. Okay, now, first step done. Second step is run your F test. So run F test. So our null and alternative will always look like this. I've told you multiple times now. All right, so we need to calculate our F stat. That is a given. You know the formula. Plugging in our values. So it should be 3.79 divided by 8.03. You can pause the video, report the answer. It's going to be 0.47. That's your F stat. That's your evidence. Now, if we want our F critical value for our upper, remember it's F of alpha divided by 2, comma, n1 minus 1, n2 minus 1. This is our upper. So for our upper, it's going to be F of 0.025, comma, 41, comma, 97. So that's what we're looking up on our F table. Now for our lower bound, it's F1 minus alpha divided by 2, comma, n1 minus 1, n2 minus 2. Or you can do this. 1 divided by F of 0.025, comma, remember we switched these two values. So 97, comma, 41. Okay. So I'm going to go in and double check these values because I think I got them wrong. So just give me 1 second. All right, so F of 41, which we don't have, so the closest value to 40, or here, we'll just go through it together. Screw it. So I'm going to clear all this. So we're trying to find is F 0.025, comma, 41, comma, 97. So we have 40, that's the closest value to 41. And then you have 97, the closest value to 97 is 100. So it overlaps right here. So this is 1.64. Remember, this is your upper. Now your lower is F of 1 minus 0.025, comma, 41, comma, 97, or 1 over F of 0.025, comma, 97, comma, 41. So this is how you would use a table for it. So now we're switching it. Now we want to see 100. We're using this column, and we're going to compare that to 40. Which is 1.74. So it's 1 divided by 1.74. We're going to get 1 divided by 1.74 is 0.57. So 0.57, these are your upper and your lower bound. So I'm going to go back to the whiteboard. So your upper bound, 1.64, your lower bound is 0.57. Again, reference back to what we just did on that table. Okay, so you have your two critical values, 0.57, and then you have 1.64. We have your rejection regions. Now, 0.47, does it fall within the rejection region? I hope all of you are nodding your head yes, because 0.47, somewhere right here. So what this means is we reject the null, and you would say assume unequal variance. Now, in order to do this, we need to carry out, we have new formulas now. So we run an F test to determine what type of T test to run. So the next step would be run your T test, and you have certain formulas for this. So that's what we're going to be doing next. Okay, so give me 1 second. So this is step 3. We are assuming unequal variance because we rejected our F test. So now our T-stat for that is as follows. So x bar 1 minus x bar 2 subtracted by mu1 minus mu2 divided by, we don't use our pooled variance now, it's a different formula. This is how it looks. So here we would plug in all the values we are given to us. So pretty standard, nothing too crazy. Oh, this should be negative 0.10. So negative 0.10 minus 1.24 subtracted by 0. Remember, we get this from our null divided by the square root of 3.79 divided by 42 plus 8.03 divided by 98. Now, if you were to do all this math, the value you would get is negative 3.22, which is already pretty high value, so you can kind of make some assumptions already. Next step is we want to know our T critical value. So our T critical value when we have unequal variance is this super intense formula. So in order to do it, you need T of alpha, obviously. So in this case, it's T critical value of alpha divided by 2. The reason why it's alpha divided by 2, it's a two-tailed test. And we find that out by this symbol right here. Our degrees of freedom, that's what's the gnarly part of this formula. I'm going to write it out. Again, I know this is frustrating. Again, you have this formula available to you on the slides. All right. So after I plug all of this in, it's going to be T of alpha divided by 2. So alpha is 0.05 divided by 2. The degrees of freedom, what it comes out to is 111. I'm going to spare you all that stuff. You can plug it in all you want. It's going to be 11 or 111. So what I want to look up on my T table is 0.025, comma 111. Now, what we end up finding is our T critical value is 1.984. It's going to be plus or minus, right? Because it's a two-tailed test. So the way this would look, these are your rejection regions. 1.984, 1.984, and then this is our test statistic. Does it fall within the rejection region? All of you should be saying yes. So we will reject our null hypothesis, and we conclude there is a difference between your offspring, and outside CEO operating income. So those are the two ways you can go about answering this question. Remember, the steps always remain the same. You have to be able to set up the null for your two-sample t-test. From there, you have to be able to calculate your run your f-test. From there, you get your decision on what kind of test you need to run. So the test that you need to run is an f-test to understand equal or unequal variances. From there, you have a certain formula for your t-stat, for your t-critical values, and then you make your decision. So it's a couple more steps, but the idea remains the same. It's always going to remain the same. Again, watch this video, go back, review, pause the video, whatever helps you in this process. Okay, another thing I want to show you all is an example like this. So this is actually one of your homework assignments, one of your problems. Now, I have this table set up. So I have group 1, group 2. I give you X bar, I give you your variance, your sample variance, I give you your sample size, I give you your pooled variance, and I give you alpha. So this is something very common that you can see on your exam. I will give you a table with information, you extract the information, all you need to know is the steps. If you know the steps, I promise you will do fine. Another example. Here, I give you your table. I give you mean, variance, observations, degrees of freedom, your alpha level, and so forth. So again, you should be able to calculate these when I give you this kind of information. This is how it's going to essentially be set up. Here we have another example. And then lastly, you also have this other example. So during our review, we were going to be doing some of these practice problems in class. So these are your homework, but we will practice them doing step by step. Again, this is great practice to help you for your exam. All right, so that's going to be it for today. I really do hope this helps. And again, I apologize that we didn't have enough time to do everything in class this week, just with timing, the holidays, and with my cough and all that stuff. But again, thank you. You're all going to do fine. Don't stress. If you have questions, please send me an email. I'm more than happy to help. I really do hope this video helps you in studying. Other than that, enjoy the rest of your weekend, your week. Be safe, make smart decisions. I'll see you all in class for our review.